When looking at probability, we need to figure out how many total possible outcomes we have for the denominator in our fraction. However, there are situations where that's a little bit more complicated than it sounds. So I'm going to look at how we can help determine the number of possible outcomes, and I'm going to start that by looking at the fundamental principle of counting. For the fundamental principle of counting, we need to consider a task that can be completed in 2 stages. Let's suppose the first stage, stage 1, has n possible outcomes. And stage 2 has m outcomes. The fundamental principle of counting then says that the total task has m times n possible outcomes. So let's look at examples of this. My first example, how many ways can you select a plumber and an electrician from 3 plumbers and 2 electricians available? Well, we have 3 possible plumbers, so 3 possible outcomes for my first task. 2 electricians, so 2 possible outcomes for my second task, and my fundamental principle of counting says I need to multiply these. So there are a total of 6 possible outcomes. My next example, how many ways can you select 2 items from an assembly line and classify each of them as either defective or non-defective? Well, we're selecting 2 items. The first one has 2 possible outcomes. It could be defective or non-defective. The second one has 2 possible outcomes, either defective or not defective. And then we multiply to get a total of 4 possible outcomes. Next, how many ways can you select a first and second place winner from a group of 4 finalists? Well, first place, we have 4 possible people who could win first place. For second place, we've already selected our first place winner, so we're down to 3 people that could win second place, since the same person cannot win both. So there are a total of 12 different ways we can select a first and second place winner. Next, how many ways can you select a plumber, an electrician, and a remodeler from 3 plumbers, 2 electricians, and 4 remodelers available? We can actually extend the fundamental principle of counting to these larger problems like this. In this case, instead of 2 situations, I have 3 tasks. The first one is selecting a plumber. There are 3 possible ways to do that. We then need to select an electrician. There are 2 ways to do that. And we need to select a remodeler. And there are 4 ways to do that. And then we multiply. 3 times 2 is 6, times 4 is 24. So there are a total of 24 different ways to select these 3 people. Next, how many ways can you form a binary sequence of length 10? So that is a 10-long sequence of zeros and ones. So we have a total of 10 different things that we're looking at. So there's 4, 5, 6, 7, 8, 9, and 10. The first one could be a 0 or a 1. The second one, a 0 or a 1. The third one, etc. So each one of these can either be 0 or 1. So they each have 2 possible outcomes. So total, we have 2 to the 10th possible ways to do this. Next, I want to look at how many ways you can form a string of 7 characters such that the first 3 are letters and the last 4 are numbers. So we have a total of 7 things that we're considering. So I'm going to go ahead and draw 7 little lines here. The first 3 are letters. We have 26 different letters. So each of these will be 26. The last 4 are numbers. Well, there are a total of 10 digits, 0 through 9. So each one of these would be 10. So total, 26 cubed times 10 to the 4th. Let's do one last example. How many ways can you select a first, a second, and a third place winner from a group of 4 finalists? So we have 4 people that could win first. We've already accounted for one of the people. We're down to 3 people that could win second. And now I've removed 2 of the people, so there are only 2 people that could win third. So we have a total of 24 different ways we can assign first, second, and third place to a group of 4.